Welcome to lecture 6.5. Alright, so we have been working with SOHCAHTOA when we're trying to solve for triangles. However, that only works for right triangles. So when one of the degrees in the triangle is 90 degrees, then we can use SOHCAHTOA. But we do run into triangles that are not right triangles. So if one is not, then we have to use other methods to find the missing sides or angles. So this is where law of sines comes into play, and this works for all triangles. What are the law of sines? Well, basically it's three ratios, and we're only working with sine. If we have a triangle ABC, so A, B, C. Once again, when you read a triangle, that's the order in which you read out the angles. Okay, so we have these three ratios, and it has to do with the angle and the side. So the ratio, sine of A, where capital A is the angle, sine of A divided by side A, and that will be the side directly across from that angle, is going to be equal to, so that ratio will be equal to sine of angle B divided by side lowercase b. Once again, that is the angle, or the side directly across from the angle. And those two are all equal to the ratio of sine C divided by little c. Okay, so we have these three ratios that exist between the angle and the side directly across from the angle. We know that these are all going to be equal to each other. So some properties of corresponding angles and sides in any triangle. So please note, the smallest angle in the triangle is going to be across from the smallest side. The largest angle corresponds to the largest side. And then the medium angle corresponds to the medium side. So for example, if you had a triangle, which was, let's say, 80, and then 45 and 55, and once again, the sum of all the angles should end up equaling 180. So make sure to always check that. Then, because 80 is the largest angle, this side will be the largest side, even though it doesn't look that way. Once again, don't always base your work off of the drawing, unless you're told that the drawing is accurate. Okay, and then 55 is the medium angle, so the medium length side should be this side. And 45 is the smallest angle, so the smallest side would be directly across from it. And that's going to be really helpful when solving for triangles. So there are going to be three cases for different triangles. The first case we call angle, side, angle. Why do we call it that? Because we're given directly in this order. We're given an angle, and then a side, and then an angle. So note, you have to be directly next to each other. It wouldn't make sense if we didn't have the B here and we had an angle, a gap, angle, and then a side. Okay, so that's not what we're talking about. Those sides need to directly be next to each other. So we'll directly have next to each other an angle, a side, and then an angle. So here's an example of this case. Solve the triangle. So real quick, let's go ahead and verify that this is actually the case. So let's see, the first thing I see is an angle, and then right after that, the next known value is a side, and then again, the next known value is an angle. So this is indeed the type of triangle, angle, side, angle. Alright, so let's solve this. And we cannot use SOHCAHTOA. Why not? Well, let's see. What would this other angle here possibly be? You never know. It could be 90. Let's see. How do we find that other angle? Well, we know the sum of all the angles should be 180. So we'll go ahead and subtract the 80 from here. So that will give me 100. Subtract the 50 from there. So that means the other angle must be 50. Okay, so this is not a right triangle, so we cannot use SOHCAHTOA, which means we're going to use law of sines. Now, one other thing to bring up. Let me go ahead and write it down here. If the angles are the same, the corresponding sides are going to be the same. What does that mean for us here? Well, notice, which you may have already seen, that we have a 50 and a 50, so there are two angles of the exact same measure. And since angle C has side of length 20, the corresponding angle for this other 50 degrees must also be 20. So wow, we're really close to having solved the triangle. The only thing we're missing is this side here, right across from the 80 degrees. Only one thing to do. So let's go ahead and use law of sines. Once again, how come we can't use SOHCAHTOA? Because this is not a right triangle. So we're going to have to use the law of sines. Now what does the law of sines states? Well, if I have sine of my a value, which in this case would be 80 degrees, divided by the corresponding angle, which is x, I know that this is going to be equal to sine of, let's say, the c value, which is 50 degrees, divided by 20, which is also going to be equal to sine of the b value, which is 50 degrees again, divided by 20. So I know all three of these are equal. So I can pick and choose which one of these which one of these three ratios I want to use to create an equation with. So once again, I'm trying to solve for a variable, so I know I'm going to include this one in my equation. And then the other two, it doesn't matter which one we pick. They're actually both the same in this case. So I'll go ahead and just pick it equal to this one. Let's go ahead and solve. So we know that sine 80 degrees divided by x will be equal to sine of 50 degrees divided by 20. Let's go ahead and solve. So once again, we did create an equation using the law of sines. So solving, let's go ahead and multiply both sides by x. And then we get x times sine of 80 degrees is going to equal sine of 50 degrees divided by 20. Dividing both sides by sine of 80 degrees. We get x equals sine 50 degrees divided by 20 sine of 80 degrees. Now plugging that into our calculator, we're going to get that x is approximately 25.71. Sorry, that's kind of squished right there. Okay, so x is approximately 25.71. Now, does this make sense with the rules that we know about triangles? Well, first off, is the inner measurement 180? The answer was yes. All of those angles added up to 180. And then, does the biggest side have the biggest number? Or not the biggest side, sorry. The biggest angle have the biggest side. 80 is the biggest angle, which means the corresponding side should be the biggest length, or the longest length. The answer is yes, 25. That's bigger than the 20s, so this matches what we know about triangles. Okay, so now let's look at case 2. This one is called angle, angle, side. So this is when we're given two angles in order next to each other, and a side. So once again, it needs to be in this order for it to be this case. So we wouldn't have a known side in between, because then this would be a side, or an angle side angle. So we have an angle, angle, side triangle, which is case 2. Let's go ahead and solve this triangle for example 2. But first, let's go ahead and verify which kind of a triangle it is. What are our known values? I'm going to go ahead and highlight them. We have a side, then an angle, and right after it, another angle. So since we have in that order a side, angle, angle, or from the other direction, angle, angle, side, you can go either direction. This is going to be the case 2. So to solve the triangle, well, one of the first things I know I can find is the other angle A. How do I do that? Once again, using the concept that the measurement inside a triangle should be 180. So we'll do 180 minus the 82 and then minus the 42. And what will we get? We'll get 56 degrees. Okay, so now we found all of the inner measurements. We just need to find the sides. What's one thing to note before we find the sides, though? Well, angle B is the largest angle, so this side should end up being the largest side number. Angle C is the smallest angle, so this side, 7, should be the smallest side. And lastly, 56 is the medium angle, which means that the side here will actually be the medium side. Alright, so what do we need to find? We need to find two other sides. I'm going to go ahead and just call them little b, little a. This is not a right triangle, so I can't use SOHCAHTOA, which means I'm going to use the law of sines. So let's go ahead and see what I have. So I know that sine of 82 degrees divided by b is going to equal sine of 56 degrees divided by a, which will be equal to sine of, the only one left, 42 degrees divided by 7. Okay, so I'm going to create some equations from here to try and solve. Notice this time, two of my ratios have variables. So I'm actually going to have to solve twice to get something. So I could not equate these two together. Why not? Because then I would have two variables to solve for. And you can't just have one equation with two variables. So I need to equate one of these with the only one that doesn't have a variable, which is sine 42 degrees over 7. So I can equate one of them with this. I'll just go ahead and choose, let's see, let's equate these two together for the first time. So I'm going to go ahead and write solving for a. So we have sine of 56 degrees divided by a equals sine of 42 degrees divided by 7. Okay, so skipping some of the smaller algebraic steps, we'll end up with a equals 7 sine of 56 degrees divided by sine of 42 degrees. Plugging that into our calculator, we get a is approximately 8.67. Okay, write that down. A equals approximately 8.67. Okay, we found one of our sides. So you might be tempted to go ahead and plug this in here and then solve these two together. The danger in that is, once again, we used an approximation for this value. So I try to avoid using approximations multiple times. So let's go ahead and keep using this value and use that to pair it up with this one to solve for b. Let me go ahead and write down what I'm doing. Solving for b. And then we'll have sine of 82 degrees divided by b equals, once again using the value that we did not approximate with. And let's solve. So once again, skipping some of the minor algebraic steps, we get 7, let's see, sine 82 degrees divided by sine of 42 degrees. Which means b is going to be approximately, plugging that into our calculator, 10.36. Okay. But first, let's check that this actually makes sense with what we know about triangles. Once again, making sure that the biggest angle has the biggest side, and so on. So b is the biggest angle, which means it should have the biggest number. And that is true. 10 is larger than the other two values we have. C is the smallest, so it should have the smallest. Yeah, that makes sense. 8.67 is between 10.36 and 7. And all the inner angles equal 180 degrees. So we're good. Our triangle makes sense. Let me go ahead and box my answer there. So now we're moving on to case 3, and this one's considered the ambiguous case. The question might be, why? Well, this is when we know a side-side angle. So I have this little diagram here, but I'm going to go ahead and explain it on the side and then erase it. So we'll have a fixed angle. Let's say we call it A. We know this one. Then we have a fixed length. Let's call this B. And we also have one other fixed length. We'll call that lowercase a. These are the only values we know. And because of the way triangles work, we end up with some ambiguity. Why? Well, this length is not known. Down here, let me go ahead and highlight it. And this angle is not known up here. That means that I could technically move this leg forward and create some triangle with the same length leg, and that could match up there. So we'd have that triangle. Or, technically, this leg could move out the other direction. Let's say here, And this length leg that we don't know could end up making it out to there. So we would have two other possible triangles to create. Because that leg is movable, because we don't know what this angle is, and we don't know what this leg is, so they're kind of free to create different triangles. The other ones didn't have that case. So because of this, the ambiguous case has some possibilities in the answer. There might be one solution, two possible triangles that fit the case, or no solution. So the triangle SSA, which I would call SA, or some students like to call the donkey version, there might be one solution, two solutions, or no solution. So it definitely is the more tricky case. So once again, when you're solving, make sure to figure out which case it is, because the ambiguous case is out there lurking. Alright, so if the given angle that we have is less than 90 degrees, there will be two choices for the unknown angle. And to find that, please remember this, subtract the given angle from 180 degrees. So let's go ahead and solve this, but first let's make sure that this is actually the side-side angle case. So what are we given? We're given a side, and an angle in that order. Yep, this is the ambiguous case, so we gotta be careful. Keep in mind, it could be one, two, or none solutions. Well, what do we know? That'd be A. So we have this ratio going on here. We have sine of C divided by, oh sorry, that's not A. That should be C. Divided by C, we don't know either of those, will equal sine of the B value, which we do know, 80, divided by 7, which is going to equal sine of A divided by 5. So these are the ratios we know. We would not put sine of C into an equation yet. Why not? Why would we not put this one into an equation? Because it has two variables. Once again, notice that lowercase c and capital C are not the same variable. So we can't put that into an equation yet. We would need to solve for either lowercase c or capital C to use that. Which means the two I'm going to use in an equation are these two right here. Let's go ahead and solve. What are we solving for? Well, the only variable in there is A, so we're going to solve for capital A. Solving for capital A. Alright, so sine of 80 divided by 7 equals sine of A divided by 5. Alright, so using algebra, we'll end up with sine of A is going to equal 5 sine of 80 degrees divided by 7. Oh, darn. Where is our variable? It's inside sine. So how do we get it out of sine? Well, this is where our inverse comes into play. So I'll go ahead, take sine inverse of both sides. Inverses cancel. And we are left with A equals sine inverse of 5 sine of 80 degrees divided by 7. Plugging that into the calculator, we get A is approximately 44.7. Now this is where things change up a little bit. Because we have the ambiguous case, we need to take into account that we could have the other possible angle with this. So we're going to go ahead and write or, and to find the other angle, we're going to take 180, let me do this on the side, 180 minus the value we just found, 44.7, to find the other possible angle. And the other possible angle comes out to be 135.3. So, or, we have the possibility that A is approximately equal to 135.3. Now, before we continue on, we need to make sure both of these cases are actually possible. Well, A equals 44.7. Yeah, that could fit into here. Let's say we could imagine it right there. It's smaller than 80, so it makes sense that it would have a smaller side on the other side. Okay, so 44.7 checks out. We can go ahead and keep working with that. Let's see if A equals 135.3 checks out. Well, if I plugged in 135.3, I know it couldn't be where angle A is. Why not? if I put 135.3 here, that means the corresponding side is 5. Well, wait a second. 80 has side 7. That doesn't make sense because 153 is bigger than 80, which means it should have the larger side. But it has size 5. So that doesn't make sense. It doesn't work with triangles. 80, technically, should have the bigger side than side A, or the angle A. Okay, so 153 does not work. Another reason to know 135 does not work is because the inside measurements should all equal 180, right? And 135.3 plus 80, what would that give me? That's 215.3. And that's just two of the angles added up. That is way bigger than a triangle's angle should be. So 135.3 breaks two of the rules for triangles. One, the interior angle would get bigger than 180. And the other thing is, it should have a smaller side than B. Okay, so 135.3 does not check out, which means it's done. So we're going to go ahead and keep with the fact that A is equal to 44.7. Let me go ahead and write that in. So A is equal to 44.7. So now let's solve for the remaining angles and sides. Alright. Ooh, well since we have two angles on the inside, we can go ahead and solve for C now. So finding angle C. Finding C. That's just going to equal 180 minus the other two sides. And we'll end up with that 180 is going to be 55.3. Alright, so now we have everything except for lowercase c side. Let's go ahead and erase that. We now have that. That is 55.3. All I have to do is find lowercase c and we're done. We've solved the triangle. Okay, so, kind of running out of room here. Solving for lowercase c. Once again, when room gets a little squishy, it's good to write your labels out. Okay, so we're going to go ahead and use sine of 55.3 divided by c equal to. Now, you might say, should we pick this value to equate it to or this value? Well, once again, always go with the one that you were given exact values for. We approximated angle A, so because we approximated it, I don't feel comfortable using it. Let's go ahead and use that value. Sine of 80 divided by 7. So solving for c with some algebra, you get c is going to equal to 7 sine 55.3 divided by sine of 80 degrees. So c is going to be equal to approximately 5.843. And there we go, we have solved for all of the sides and all of the angles with the weird ambiguous case. So one of the main differences for the ambiguous case is once you find one of the possible angles, you need to subtract from 180 to see if there is the possibility of two possible triangles happening. Once again, once you've solved for one of the first angles, you got to do the minus from 180. Let's take a look at example 4. Solve the triangle ABC, where angle A is 40 degrees, A equals 11, and B equals 9. So first things first, let's go ahead and draw this to see what we have. We have a triangle ABC. So if I draw in a triangle, I'll go A, B, and C. Well, I know A is 40 degrees. And then lowercase a is 11. So where is lowercase a going to be? Once again, lowercase a is directly across from angle A. And then B is 9, so it's going to be directly across from B. So what do we have? It looks like we have an angle side-side, or also a side-side angle. So this is the ambiguous case. Oh dear, which means we have the possibility of having one solution, two solutions, or no solution. Let's go ahead and set up the ratio that we have. Let's see, what are we missing? Well, we have sine of c divided by c. We don't know any of those. Then we have sine of 40 degrees divided by 11 equal to sine of, we don't know what b is, but we do know lowercase b, which is 9. So once again, what should we solve for? Well, sine of c over c, that has two variables. We're not going to use that just yet, which means we're going to go ahead and use these two to equate and solve for the only variable they have, which is capital B. So we'll solve for capital B. So sine 40 degrees divided by 11, forgot the degree there, equals sine B divided by 9. So solving for sine of B equals 9 sine of 40 degrees divided by 11. Okay, to solve this, since the B is inside of sine, to get it out, we're going to have to take the inverse of both sides. So we'll have sine inverse, oops, wrong color, let me change that. Sine inverse of both sides. And we get sine inverse, oops, sorry, nope. We get B equals sine inverse of 9 sine 40 degrees divided by 11. Plugging that in, we get B is approximately equal to 31.73, 31.73. Okay, once again, this is where we pause. We have found the first of the two missing angles. So we have to have the opportunity, or find out, whether the other angle could exist. So we'll subtract our found angle from 180, and what do we end up with? We get 148.27. 148.27. Okay, so that's telling me that angle B could be 31.73, or B could approximately be 148.27. We need to see if either one of these would not work. So once again, we'll plug them into our triangle and test them and see when they work, or if they work. So if B was 31.73, well, I know that these two added together are still under 180, so it's the possibility of having some other value for the angle there. Okay, good, so that works. Next thing is to compare the angles with the sides that we have. So let's see, angle A is 40 degrees, and angle B would be 31.73, and their corresponding sides, do they make sense? Well, since B is smaller than 40 degrees, it should have the smaller side, and that is what happens here. B corresponds with side 9, and 40 degrees corresponds with the larger side, 11. Okay, so 31.73 does check out. Now let's check 148.27 with those two things that we had before. So if I plug in 148.27, I already see a problem here. 148.27 plus the degree that we do have, or the angle we have, 40, that is going to be larger than 180. That is going to be 188.27. That's only two of the angles. We would still need to find one other one. So already we know that B doesn't work. We could have used the other reasoning, which is the fact that since angle A is 40 degrees, and it has a side equal to 11, and B has side 9, B should be smaller, because B is smaller than 11. Okay, and 148.27 is not smaller than 40 degrees, so it doesn't make sense with the information we are given. So B strikes out 148 strikes out for two of the reasons we check for. So we're only going to have one solution. So we know that B is going to be equal to 31.73. So now let's go ahead and find angle C. We can do that because we have the other two angles. So let me go ahead, plug that in. We have 31.73 for angle B. So finding C, that's going to be 180. Minus the 31.73 and minus the other angle, which is 40 degrees. We'll end up with that C is approximately 108.27. Okay, small triangle, 108.27. So once again, because it's hard to label the triangle, that's why it's a good idea to label your work and then box your answers. Alright, so we'll box that for C degrees. Now the next thing, the only side we're missing is side C. Let's go ahead and solve for that. So solving for lowercase c. Which ones can we use from our ratios above. Which ones? Well, I'm not going to use this one. Why? Because once again, we find the approximate value for b, so I won't use that. I'll use the one we already have that has all the given actual values. So we have sine of c, which we found out was 108. You might say, but why are we using this approximation? Because we're sort of forced to use this one. Equal to sine of 40 over 11. Solving for c, we get that c is equal to 11 sine of 108.27 over sine 40. Okay, and then c is going to be approximately 16.25. I'm not really going to sort of fix it. It doesn't really look that good up here. So once again, because it's sort of hard to label the triangle sometimes, just box your answers and make sure to label your work to tell me what you were solving for. Okay, so try example 5 by yourself and check in with me in a second. Alright, so example 5, we're told to solve the triangle ABC, where angle A is 43 degrees, A is 19, and B is 25. So we're given two sides and an angle. Let me see here. So I'll call this ABC. And we're given A is 43. Side A is 19. And side B is 25. Okay, so this is the ambiguous case, which means we have to be prepared for the possibility of one solution, two solutions, or no solutions. So let's go ahead and set up the ratios that we do have. Well, once again, sine c over c, we don't have either of those values. That'll be equal to sine of b over 25. It doesn't matter how we set up these ratios, by the way. They're all equal to each other, so it doesn't matter who comes first, second, or last. And then that's going to equal to the only one that we know all the values for, which is sine of 43 degrees divided by 19. Okay, so which one do we start solving with first? Well, we can't use sine of c because, once again, it has two variables, so we have to wait on that one. So we're going to go ahead and solve for capital B using this ratio right there. So let's go ahead and write that out here. So solving for b. So we'll get sine of b over 25 equals to sine 43 degrees over 19. And then let's go ahead, so solving, we'll end up with 25 sine 43 degrees over 19. Darn. So b is inside of sine, which means we're going to use sine inverse to solve. Those cancel out. So we have b is going to equal sine inverse of 25 sine 43 degrees divided by 19. Plugging that into the calculator, we get b is approximately equal to 63.81. And once again, this is the first angle we found, which means we need to take into consideration the possibility of another triangle. So 180 minus 63.81, that gives us 116.19 as the other possibility. We need to see if both of these check out. So let's go ahead, plug the first one in, and see if it works. 63.81. It is larger than 43 degrees, which means that it should have the larger side, and that makes sense. B is 25, and then the 43 has the smaller value of 19. If I added the two angles up, do I have space for a third angle? The answer is yes. 63.81 plus 43 degrees, we still have space for another angle. Awesome. So this one checks out. Let's go ahead and check the other value. So far we haven't had luck in finding the second angle that works. So plugging in 116.9, or 19, sorry. 116.19, it is bigger than 43, so it should have the bigger side. And yeah, that checks out. Okay, so that works. Next, if I added 116.9 plus 143, would there be space for another angle? The answer is yes. 180 minus 116.9 minus the 43 would give me 20.81. So we would have space for another angle for C. That hasn't happened before. So you know what? 116.19 checks out on both of the criteria. So we now have that interesting case where we have two possible angles, which would give us two possible triangles. Aha! Okay, so they both work, which means we have two different triangles. So let me go ahead and erase this. I'm going to go ahead and draw in our new two triangles that we're going to work with. Okay, so let's see. So we have option 1 and option 2. Let me go ahead and do this. Oh, sorry, triangle 1, triangle 2. Triangle 1. Let's see, the values we knew before were 43, 19, 25, and we're going to go with the option of B equal to approximately 63.81. So that is triangle 1. Then we have the possibility of something for triangle 2, where B is going to be approximately 116.19. So we have this other triangle here with 116.19 for B, and then 43 for A, sides still are the same there and there. So the only thing remaining now we have for each of these triangles is to find capital C and lowercase c. So let's go ahead and do that. So for the first one, we'll go ahead, so sine of C, how do we find capital C? Well, we can find the interior angles by subtracting these two values from 180, which we have been doing, so I'll go ahead and do that. Subtracting them from 180, we get that C should equal approximately 73.19. So C is approximately 73.19, and setting that equal to the value that we didn't approximate, because once again, try to stay away from approximations as much as possible. That's going to equal sine of 43 over 19, which means that C is going to be equal to 19 sine of 73.19 degrees divided by sine of 43 degrees. So C is going to be approximately equal to 26.67. Once again, though, we still have to check and make sure this all makes sense for the first triangle. The interior equals 180, check, and then do all the sides match up with what we know they should match up to. So the largest side should have the largest number. That makes sense there. 73 and 26.67 are the largest sides. The medium angle right there has the medium side, and then the smallest angle has the smallest side. Okay, this triangle checks out. Awesome. So we have figured out the first triangle. Now let's look at the second triangle. So we still need to find capital C and lowercase c. To find the interior angle, we'll subtract these two from 180. So subtracting those two from 180, we get the other angle side that's possible is 20.81. Okay, so we know sine of 20.81 divided by the value we still don't know yet, which is lowercase c, will be equal to, and we'll go ahead and pick sine of 43 divided by 19. Once again, we pick this one because the least amount of times that we play with approximated numbers, the better our actual answer will be. So C is going to equal 19 sine of 20.81 degrees divided by sine of 43 degrees. So C comes out to be approximately 9.9. We got to check to make sure this makes sense with our triangle. So once again, make sure the interior angles equal 180, which they do. Then check, does the largest angle have the largest side? Largest angle, yeah, that's the largest side. Middle angle has the middle side. And then smallest angle has the smallest side. So this triangle checks out. Wow, okay, so we have found two triangles that fit the requirements we were given. Awesome. Okay, so that is one of the cases where the ambiguous case gives us two possible triangles. So now let's take a look at example 6. Okay, so solve the triangle ABC, where angle A is 40 degrees and side A is 100 and side B is 200. So let's go ahead and set this up. Let's see, 40, I'll call this A, B, C, with 40 degrees. A equal to 100, B equal to 200. Okay, so one thing I'm noting right now is that B, should it be a larger or smaller angle than A? What do you think, larger or smaller? It should be larger. How do I know that? Well, side A is 100 and side B is 200. 200 is bigger than 100, so B should be a bigger angle than 40 degrees. So I just know that off the bat. Now, how will I solve this? Well, let's go ahead and set up our ratios and then see what we can solve. So sine B, 200, equal to sine 40 degrees over 100. Once again, we can't use any of the C values because there are two variables on that side. So go ahead with these ones. And let's solve. So what are we solving for? Solving for B. So sine of B over 200 equal to sine 40 degrees over 100. Then we'll get sine B equals 200 sine 40 degrees divided by 100. Hey, look, we can simplify the 200 and 100. Question, real quick. Could I simplify the 100 with the 40? The answer is no, 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 no. Why not? The 40 is inside the function sine, so you can't touch that. All right. Okay, so then we have sine of B equals 2 sine 40 degrees. The value we're looking for, or the variable we're looking for, is inside of sine, so how do we solve for it? We'll go ahead and take the inverse of both sides. And we have B is going to equal sine inverse of 2 sine 40 degrees. Okay, we'll go ahead and plug that into our calculator, and then, oh no, if you plug that into your calculator, you are going to get this on your calculator. It says error, domain, and then it'll have 1, quit, 2, go to. Okay, we have an error domain. What does that mean? Well, this is telling us there is an error with the domain. So first, let's take a look at what 2 sine of 40 is. So plugging that into my calculator, 2 sine of 40, I get B is going to equal approximately, let me rewrite that, B is approximately sine inverse of 1.49, so on. But we have to remember, what is the domain for sine of sine inverse? So sine inverse of sine x, the domain is -1 less than or equal to x less than or equal to 1. So 1.49 is outside of the domain for sine inverse of sine, which means there's no solution. Okay, so if there's a domain error, you have no solution. So our answer is going to be no solution. Now, if you just wrote no solution and you didn't mention the domain error, you wouldn't get full credit for it. So please, if you ever write no solution, write the reason why you know that there is no solution. Okay, so if you write calculator says error domain, that would be perfectly acceptable as well. So once again, no solution because we're outside the domain. Now let's look at, oh, that should be a 7. Example 7, refer to the image. Okay, so what do we know on our images? Or what do we know on the image? It looks like we have angle, side, angle. Okay, so this is not going to be the ambiguous case, so we don't have to worry about 1 solution, 2 solution, or no solution. The possibility is 1 solution. Okay, so can we find any of the other information? Well, since I have 2 angles already, I can go ahead and find this third angle right there. So subtracting, let's see, what will I call this angle? I'll call this B. That'll be lowercase b. So we're going to find angle B. So finding B, that's going to be 180 minus the 35 degrees from there, and then minus the 15 degrees. And we'll end up with the angle of 130 degrees. Okay, so I have 130 degrees. We filled in all of the angles. Good. So now I'm trying to find A. Using the law of sines, what can we set up? Well, A corresponds to 135, so I know I'm going to use that. So sine of 135, sorry, not 135, sine of 35. So sine of 35 over A equals, and then do we have any of the other ratios? Well, we can't use 15 because we don't know the side for 15. But we can use 130 because we know the side for 130, which is 20. So sine of 130 divided by 20. A is going to equal 20 sine of 35 degrees divided by sine of 130 degrees. Putting that into our calculator, we get A is approximately equal to 14.97 miles. And then, okay, that was part A. Hey, look, we finished part A already. What does part B say? Find the elevation of the plane. Elevation, what is that talking about? Well, that is talking about the distance from the ground to the plane. Let me go ahead and draw another picture for B so we can see this better. So we're talking about from here. We want that side right here. How will we find that? Well, what do we know? We know that this whole length is 20. We know that this whole length is 14.97. And what else do we know? We know that this is 35, 15. Hey, since we're dropping a straight line from the top to the bottom, we create something called a right triangle. So I know that that angle right there is 90 degrees. Aha, I just said that beautiful magical number, 90 degrees. We're talking about a right triangle now. So since we have 90 degrees, we can bring back SOHCAHTOA. So we're trying to find this right here. So we go ahead, we also have that 90 degree on this side as well. So let me blow up the triangle I'm going to use, not blow it up, but I'll make it bigger. So I'm focusing on this section here. We have the 90 degrees. We're trying to find this length here. And what else do I know? I know that this is 14.97. Anything else that I know? I can't use 20 because 20 includes this whole length. So we don't know what this section is here. But I do know that this is 15 degrees. And I'm trying to find this value here, which I will call h for height. Okay, so what do we have and what can we use from SOHCAHTOA? Once again, we're using SOHCAHTOA instead of the law of sines because this is a right triangle. Well, the angle I have for 15 degrees, I have the opposite values that I'm trying to find, and I'm given the hypotenuse. So which trig value uses opposite and hypotenuse? And I kind of gave it away, it's sine. So actually we are going to use sine again. So we're going to use, so this is solving for h. So we have sine of 15 degrees is going to equal, once again, sine of x is equal to opposite over hypotenuse. That's from SOHCAHTOA. So the opposite value is h, which we're solving for, and hypotenuse is 14.97. So h is going to equal sine of 15 degrees times 14.97. Plugging that into our calculators, we get h is approximately 3.88. And once again, because of your given units, we're going to answer with units, and the answer is miles. Okay, so we were able to combine the law of sines and SOHCAHTOA into one problem. And once again, the main difference between using them is whether or not it's a 90-degree triangle, or a right triangle. Alrighty, that is it for section 6.5. These are the practice problems. Once again, they will be up by the end of the week, and they are not due for the summer session. Other than that, please email me if you have any questions.